So number one, what angle is formed by ray XY and ray XZ? Well, ray XY is this ray right here. And ray XZ is this ray right here. And so this is the angle that we are looking at. And we want the name of that angle. There are a lot of correct possible answers here. One of the answers comes from this little number that's tucked into the corner. Notice that little number is touching both of these sides here. So we could call this angle 1. I could also call this a 3-letter name. If we're going to name an angle with 3 points, we need a point that is to the left or on one side of the vertex. Then we name our vertex, our turning point. And then we need a point on the other side of the vertex. ZXY would work. Angle ZXY. Does what have to have what? Inside. Yes, it has to be on the inside if we're going to name the angle that way. Yes. ZXV also works, yes. ZXV. Thank you. I can take either one of those names and I could turn it around. I can go the other direction. So instead of ZXY, I could call it YXZ. Instead of calling it ZXV, I could call it VXZ. Notice on all of the ones that we have named with 3 points, X, this place where we turn, is right in the middle. Your vertex, your turning point, has to be right in the middle of your name for that angle. So we need a point on one side of the vertex. We need to know exactly where we are turning. And then we need a point on the other side of the vertex. It's kind of like if you're giving directions to somebody. You're like, okay, I want you to start by the McDonald's. And then you're going to drive down the road until you see CVS. At CVS, you're going to turn left. And then you'll go past the gas station. So you give a point where you're starting from. You give the point where you turn. And then you give a point somewhere in that direction so they know they went the right way. What else would you guys like to see? 6 and 7 sounds great. Yep, 6 and 7. Those are both problems that I think are well worth our time. All right, so on number 6, we use this same picture for both of these because it says use it for 6 and 7. And it tells me that ray TP and TS, here's TP, here's TS, those are opposite rays. That means that they form a line. They form, they'll make adjacent angles. The rays, when they're put together, form a line. And then it says that ray TQ bisects, well, TQ is this ray right here, and it bisects angle RTP. So R up to T, turn at T, and then go over to P. This is the angle that is being bisected. What does bisect mean again? Cuts in half. So if that orange ray is cutting my blue angle in half, what do we know about these two angles? They are congruent. So we'll be able to set their measurements equal to each other, yes. So let's go through and look at what our angles are. PTQ is 12x plus 4. P over to T down to Q. That is 12x plus 4. And then RTQ, starting at R, up to T, down to Q. That is 15x minus 5. And those two angles are the same size as each other. So we are going to set their measurements equal. Angle PTQ is congruent to angle RTQ. So the measurement of angle PTQ is equal to the measurement of angle RTQ. Angle PTQ is 12x plus 4. And so we equal that to 15x minus 5. And now we're going to solve this for x, which means I need my x's on the same side. So I'm going to minus 12x from both sides. So I have 4 equals 3x minus 5. Then I add 5 to both sides. I get 9 is equal to 3x. And then I divide both sides by 3. And I get that x is 3. What do they want me to find in this problem? RTP, which is this big blue angle here. There's 3 different ways I could do this. 2 of them are really similar. One of the ways I could do this is I can take that answer for x, I can sub it into both of these, and then I can add them together. Because together they make the big blue angle. But what do I know about these 2 angles? They're congruent, they're the same size. So if I find one of them, I know the other one. So we could just times it by 2. I could find the top one by plugging in for x and times it by 2. Or I could find the bottom one by plugging in for x and times that by 2. So the measurement of angle RTP, I'm going to do one of the times 2 methods, is 2 times the measurement of angle PTQ. So the measurement of angle RTP is equal to 2 times 12x plus 4. So 2 times 12 times x. We found out that x was 3. So 12 times 3 plus 4. What's 12 times 3? 36 plus 4? 40. So 2 times 40 would give me 80. Measurement of angle RTP is 80 degrees. So we learned that this angle is 40 degrees, and so this angle is also 40 degrees. So when we put them together, we get 80. Number 7 uses the same picture. So I'm going to redraw the picture for number 7 so that we can mark it all up. All right, so there's my basic picture. We have a point S here, T, P, Q, and R. Nope. There are some problems, though, where it is just what they give you. Okay, so we got to look at what's being bisected. Remember, we said that TQ, this right here, is bisecting angle RTP, this blue angle here. So we have this angle is the same size as this angle, but the angle that they've given me, STR, here's S, over to T and down to R, this angle right here is 102. And that's not the angle that's been cut in half. So to solve this, the first thing I'm going to do is pretend like I can't see this line right here. They want me to find the measurement of angle PTR. And the light blue and dark blue angles, notice they share this side right here. They share a side and together they make a straight line. Does anybody remember what we call that? Linear pair. So these two angles form a linear pair. Close, not 90. 180. They add to 180. So 102 degrees plus the measure of angle PTR is equal to 180. So then I'm going to minus 102 from both sides. And I get the measure of angle PTR is 78 degrees. So this angle right here is 78 degrees. Now they also want me to find QTR. QTR is just one of those little baby angles inside PTR. And what do we know about these two angles here? When I put them together, I get 78. They're equal, they're the same size. So if I know that when I put two things together, I get 78, what can I do so that I can figure out how big each one is if they have to be the same size as each other? Divide by 2. Yes. The measure of angle QTR is equal to 78 degrees divided by 2. And you said that's how big? 39. So the measurement of angle QTR is 39 degrees. We had a question like this on the first skills check that we took in this module. And then it's showing up again on the test review. And we had examples like this in the notes and on the homework. What do you think that means?
It's not already on the test.
Oh, definitely not at all. I am wasting everyone's time. There will be a question like this one on the test. Please make sure that you know what to do with these problems. Yes. What else would you guys like to see from the review? Which one? 15, 16, you asked for 15? Oh, 6, 8, 15, 16. Okay, I'm going to go to 8 since we're right there, and then I'll go to 15 and 16. All right, 8. Says that angles M and N are complementary. What does complementary mean? It means they add to 90. Two angles that add to 90. So I noticed on the skills check yesterday, there were a couple things that went on, and this was scattered across all my 4 classes, so I'm not talking to anybody in particular in here. Sometimes we got confused about things and always set things equal. You can only set them equal if they're the same size. If it says complementary or supplementary, they're probably not equal to each other. Like almost guaranteed not equal to each other. Complementary means they add to 90. Supplementary means they add to 180. And there seemed to be a good bit of confusion about which one meant which. And I want to make sure that you guys can remember this for the test tomorrow. Because on the test, since part of what I'm testing is do you know the vocabulary, I won't be able to tell you this. Here's a stupid little trick that I have used to remember which is which. I think about a number line, and I think about the alphabet. On a number line, which one comes first, 90 or 180? 90 comes first on the number line. Which one comes first in the alphabet, C or S? C. So if I put it in alphabetical order, complementary comes first. That goes with 90 degrees. Later on down the number line and later on down the alphabet, we get 180 and supplementary. So further down the number line, further down the alphabet, those go together. Complementary and 90 go together. First on the number line, first in the alphabet, between those two. All right, so when I see that two angles are complementary, the first thing I do is I put two blank lines like this with a plus sign in between, and I equal it to 90, so that I remember I need two different pieces added together here. Then it says the measure of angle M is 38 less than. This is another spot where we had a little bit of confusion. 38 less than means I'm going to do minus 38, not 38 minus. Where the subtraction sign goes matters, and it will drastically change your problem. If you're struggling to remember, is it 38 minus or minus 38, turn it into a money problem. If I have $40 and you have 38 less than me, how much do you have? I have 40. You have 38 less than me. You have 2, right? Did you do 38 minus 40 or 40 minus 38? 40 minus 38. So it's something and then 38 less, minus 38. We're going to take 38 away from the measure of angle N. And I don't know how big that is, so I'm going to call that X. So we have the measure of angle M and the measure of angle N. Angle N we're calling X. Angle M is 38 less than, so minus 38, the measure of angle N, so X minus 38. These are the two things, the two angles that go on my lines, X and X minus 38. Then we combine our two X's together. So I get 2X minus 38 equals 90. Then I add 38 to both sides.
Could you do the minus 38 and where did you get the X?
Lyndon's question and then Samaya's question. Could you do X minus 38 and then plus X equals 90? Yes.
Okay.
You can do that.
No.
Oh, sorry, 38, not 3.
No, for the one in the red. You move the 38 before the X and take away the and then add a plus for the X.
I'm trying to make sure are you saying can we have this 38 minus X?
The other red.
Yeah, so if this was X minus 38 over here and this one was X,
Not any blue or red, just the red.
just the red.
On the other side. They're like beginning.
Are you talking about over here?
Yeah.
Okay.
You move the 38 in front of the X and then add the X.
No. It says less than, so it has to be a minus, and it has to come afterwards. And then, where did the X come from? It says it's this one. You understand? Okay, so we're calling angle N X. That's just the name that I've given it, right? Kind of like I could give everybody in this room their desk number, and then I can say, oh, desk 12, desk 5. I'm just calling it that piece. The angle M says it's 38 less than this. So I have to start with this, and then we have to minus 38 from that. The way English works and the way we write our math equations sometimes are backwards from each other because they gave me the piece that I need first at the end, and the part that has to go at the end is what they gave me first. These are great questions, guys. These are fantastic questions. Because I feel like once we get these two expressions set up, we did a really good job of solving it then. So getting these expressions written down is the tricky part. When they describe it like this, when you have a word problem of something is this many less than something times whatever, I'm going to have one angle that's just x. The other angle is going to have x in it. If it says less than, at the end, I'm going to have a minus whatever that is. The multiplying and the variable have to come first. All right. You guys okay if we pick back up solving now? Cool. So I have 2x equals 128. Then we divide both sides by 2. And I get that x is 64. So angle n has to be 64 degrees because we said angle n was x degrees. So the measurement of angle n is 64 degrees. The measurement of angle m is 64 and then 38 less than that. So take away 38. You should get 26. And I have a way of checking my answer at the end. Add them together. They said they were complementary, which means they should add up to how much? Should add up to 90. 4 and 6 is 10. Carry the 1, bring down the 0. And 6, 7, 8, 9. I get 90 degrees. So we are good. (15) and 16 are the next two that we're going to do. (15) and 16.
Yeah.
Okay, log your name on the phone.
Did I get my name on the board?
Yes. That's how I knew to come and ask you. It happens. On the test, I want to say 12 questions total, and that includes 2 multiple choice. So the review is a lot longer than the test. All right, 15 and 16. On number 15, I have a measurement for this angle over here. It says it's 3x plus 6. And this angle over here says it's 54. Does anybody remember what we call angles that are on opposite sides of the x? Vertical angles. Yep. And what's true about vertical angles? They're equal. They're always going to be congruent to each other. So this angle here is the same size as this angle over here. So I can take 3x plus 6 and set it equal to 54. Then I minus 6 from both sides. I get 3x is 48. Divide both sides by 3. And we get 16, absolutely correct. For number 16, we start off in a really similar way. 16, I have x's and y's. I want to work with just one of those at a time. The only place that I have y is right here. But there are 2 places that I have x. I have x here and x here on opposite sides of the x. So what does that mean about those? They're vertical angles. They are the same size as each other. So we're going to take those expressions and set them equal. 3x minus 16 gets set equal to 5x minus 110. Get our x's to the same side first, so I'm going to minus 3x from both sides. So negative 16 equals 2x minus 110. Then we add 110 to both sides, because we want to get x all alone. Yes. Yes, you may. We get 94 equals 2x. And then we divide both sides by 2. We get 47. All right, so that finds x for us, but now we still need to find y. Well, this angle up here and the angle that has y in it, this angle right here. Do you see how they share this side right here? And together, those two angles make this straight line. What do we call an angle pair like that? A linear pair. And what's the relationship for linear pair angles? Are they the same size? No. So what do I do with it? Combine them, because they add up to what? 180, yes. They add to 180. So I'm going to take two things, add them up to 180. One of those things is y, and one of those things is 3x minus 16. So I have y plus 3 times, we just found out that x is 47, minus 16 equals 180. And now we're going to do just the number part into our calculators. 3 times 47, and then minus 16. 125. So y plus 125 equals 180. And then we minus the 125 from both sides. We get 55. Yes.
If we don't write the degrees when we write the answer.
So short answer, no. Longer answer, not all of our answers get degree symbols on them. When our final answer is an angle, that's when we would want to put degrees on it. Here, I didn't put degrees on my x's because x isn't an angle. X is part of the expression for an angle. But short answer is, if you solve it correctly and the only thing you forget is the degrees symbol on it, I will probably draw that in as I grade your test, but I'm not going to take off any points because you don't have it. If you add it when you're not supposed to, I just cross it out. Yep.
So it's not going to affect that.
It should not change your grade. No. It's one of those things that by the time we get to May, I want you guys to have a strong understanding of when we do and don't use it, but I'm not going to take points off because that's not one of the essential features. Yep. What else would you guys like to see?
I want to see 9.
Number 9? Absolutely. Did somebody have another request? Which one? 27? All right, so we'll do 9 and then 27. If I've got time, let me look at it. 9 and 10. Yeah, I have time for both of those, and I still have time for 27. Okay, so it says that CJ, and CR are opposite rays. That's a nice long way of telling me that they form a straight line. And then it says that CW, this ray right here, bisects angle RCP. CW bisects RCP. And CL, this one right here, bisects angle CJN. Or sorry, JCN. J down to C and then over to N. So what do I know about these two angles here? They share a side, but it said bisect. So they are equal, yes. These are the same size as each other. Same kind of thing is going on down here with these two, because CW is bisecting. These two are the same size as each other. The measure of angle JCL is 6x plus 3. Here's JCL. 6x plus 3 degrees. And LCN is this angle right here, is 8x minus 13. Those two angles, because this is a bisector, and we said that means these two angles are the same size. What do I do with things that are the same size? Make them equal to each other, yes. Angle JCL is congruent to angle LCN. So the measurement of angle JCL is equal to the measurement of angle LCN. So now we substitute 6x plus 3 is equal to 8x minus 13. Get our x's to the same side, so I'm going to minus 6x from both sides. I get 3 is equal to 2x minus 13. Then I add 13 to both sides. I get 16 is equal to 2x. And then we divide both sides by 2. And I get that 8 is x. What did they want me to find here, though? JCL. The measurement of angle JCL was what? What did they give us? 6x plus 3. And we just figured out that x is 8, so I have 6 times 8 plus 3. What is 6 times 8? 48 plus 3? 51. This is an angle final answer, so I am going to put degrees with this one. Yep, we're going to stay on the same screen because we're going to go do number 10 next. And we're using the same picture, so I'm going to recopy it down here. We have R, W, P. J, C, L, and N. It says that JCN, so from here all the way to here, this big angle here. Where's the what coming from? This? That's just an angle symbol? The N. Oh, the M? That means measure of. Yeah, that means measure of. Right, so big angle, JCN, is 8R minus 2. Little angle, LCN, this angle right here, is 3R plus 15. What do we know about these two angles here? these little ones? What did we say about them? We said that they're the same size. They're congruent because CL is bisecting JCN. So this over here would also then be 3R plus 15 because it's the same size. And when I take those two smaller angles and I put them together, I get that big angle, JCN. So the measure of angle JCL is equal to 2 times the measure of angle LCN. JCL is 8R minus 2. LCN is 3R plus 15. We need to take the 2 and distribute it. So 8R minus 2 equals 6R plus 30. Then I'm going to minus 6R from both sides. 2R minus 2 equals 30. Then I add 2 to both sides. 2R equals 32. Then we divide both sides by 2, and R is 16. They wanted me to find the measure of angle JCL. Well, the measure of angle JCL is equal to the measure of angle LCN. So the measure of angle JCL is equal to 3R plus 15. Measure of angle JCL equals 3 times 16 plus 15. Yes. We too close to the bell. Sorry. So that'd be 48 plus 15, 63 degrees. And then 27. Number 27. Right towards the end. This is the last thing we'll have time for. Which letter? Sorry, wrong place. Angle symbol. Measure of angle JCL. Okay. Rays RS and RT are perpendicular. That means they make a right angle. So that's the first thing I'm drawing. RS and RT make a right angle. Point V lies in the interior, so there's a point V here, and there's a ray there. SRV is 9J minus 44, and VRT is 6J plus 14. And those two angles together add up to how much? What do those two angles add up to? 90. Those add up to 90. When I have two angles that are inside a right angle together, they add up to 90. So 15J minus 30 equals 90. Add 30 to both sides. We get 15J equals 120. Divide both sides by 15. you get that J is 8, and then you take that 8 and you plug in for both. I have already posted the answer key in Canvas. If you go to our daily page in Canvas, go to the day that says Wednesday the 28th, review for Module 2, test, day 2. Scroll all the way to the bottom. The answer key is down there. All the videos from my 4 classes will be posted today. Check out videos from other classes to help you study.